Okay. Question 1. You have the parent function f of x is equal to 1 over x. And it has been transformed into it is shifted 3 units blank and shifted 4 units blank. Okay, so this is that transformations of function stuff we did a while ago. Remember I told you if you have something in the parentheses, it looks like the opposite of whatever it is. I shouldn't do y. I don't fucking know what to put here. Whatever. It should do the opposite of what it says, so if there's a negative in there, it's not going to go this way. It's actually going to go this way. So there's a positive. So my eraser's tiny. It's going to do the opposite of what it looks like. So it's actually going to go to the left. And then when it's on the outside, it does what it looks like it does. And it goes down 4 units. 2, 4, 8. Okay, just like I told you in the last video, when you have f of x, you have x and y values. The inverse of x, you just flip them around. So the inverse of 4, 8, and 5, 9 would be 8, 4, and 9, 5. Is that this? No. So it's false. 3, f of x is equal to... Oh my god, Siri's talking. I didn't say anything to you, girl. Okay, this is one of those ones that's really easy and you can do the cheat code thing that I told you about, but so if you look at it in regard to x, the first thing that happens is it's multiplied by 5 and then subtracted by 1. Flip them around and then you've got subtracted by 1 and multiplied by 5, and then do the opposite. Oops. So you add by 1 and divide by 5. So we add 1 to x and then divide by 5, and that's the inverse. But if you want the long way to do this, you take this, f of x, turn f of x into y, swap y and x, solve for y, you'll never guess what it's going to be, and then turn y into f inverse of x. Wow. So this is your answer for part A. Now we gotta graph it. So x, right? X, f of x. Just pick random fucking numbers, guy. Guy? Yeah, guy. 5 times 1 is 5, minus 1 is 4. 5 times 2 is 10, minus 1 is 9. The inverse, like I just told you in the last problem, you just flip those around. What do we need? 9, 4, 1, 2. Okay, for f of x, we have 0 on x, negative 1 on the y, 1 on x, 4 on y, 2 on x, 9 on y. Negative 1 on x, 0 on y, 4 on x, 1 on y, 9 on x, 2 on y. Jeez. They're going to give you pictures of graphs. You just pick which one is the right one. I recommend zooming in as far as you can and making sure that at least one of these points is actually being touched. Okay, what the frick is next for? Find vertical asymptote and holes if there's any. F of x is equal to x over x plus 9. To find the vertical asymptote, you just set the denominator equal to 0. I shit you not, that's it. That's literally it. That's the answer. Oops. Okay. Okay, so then it'll give you some tables. Okay, so technically we know that it says g of 8, but we technically know that it's an x value in there. So you want to look at your g of x table, and you want to look at the x side, because that is what goes right there. So we're looking for 8. Here's 8. And when x is 8, g of x is equal to 4. So we've got f inverse of 4 is what we need to find. But we don't have a table that says f of inverse. But you remember what I tell you when I tell you things. So you know that we just need to flip the values around. Okay, so we're looking for 4. on the x side. Here's 4, and when x is 4, f inverse of x is 0. That's it. Okay, what's next? 6. Okay, to figure this out, just find the inverse of 4x. Change fx to y. Swap x and y, solve for y. Replace y with f inverse of x. Yes, they are inverses. It's going to then ask you, oops, what this equals and what this equals. When they are actually inverses, it should just come out to x. But we can do it just so you can see. So f of x is 4x. So anywhere there's an x in f of x, put f inverse of x. We know 4 is technically 4 over 1. These cancel. It's x. Great. The first one works out. Now we need to put f of x in f inverse of x. Or did I just do that? I just did that. We need to do the opposite. We put 4x. Yes. So when it asks you what these are equal to, the answer is x. And yes, they are inverses. So that was 6. It'll say something like, does this function have an inverse? The way we check this is by doing the horizontal line test instead of vertical, which is how you check for a function. We go this way now. And if there's 2 points on the horizontal lines, then no, it's not. It doesn't have an inverse. But this one only hits these lines at 1 point. So yes, it does have an inverse. Under the water, take a breath for the Father. Everything just keeps on repeating. So misleading. This is your baptism, and you can't forgive them. This is your baptism, and you can't. Okay, we solve. Just set them equal to 0. That's literally it. Now we can make our sections. If you were looking at a number line, and this is negative infinity, and this is infinity, and we've got -7 to 7. Everything just... This is one section. This is one section. and this is one section. You start from the negative side, going to the positive, and that is how you find your sections. So I'm not just guessing with the sections, like, there are correct sections. Baptism, and you can't forgive them. Okay. Now this is the part where we do test points, and you honestly don't even have to get the values right. You just need to know if it's positive or negative. So you need something that's in between negative infinity and negative 7. Negative 8. In between negative 7 and 7, 0. In between 7 and infinity, easy to just do 8 because we've already done negative 8. Or we will have already done. So, just plug your test points into this. Negative 8 plus 7, that's negative 1 over negative 8 and negative 7, negative 15. 1 over 15. Doesn't matter what it is, we just need to know if it's positive or negative. 0 plus 7, 7. 0 plus negative 7, 7. This is negative 1. Negative. 8 plus 7, 15. 8 minus 7, 1. 15. Positive. This is greater than, so we need positive values. If it was less than, we would do the negative values. So, because it's not greater than or equal to, we're going to only do parentheses and exclude all these values. Where's my purple? I've lost it. We're on the wrong... On a number line, we go from negative infinity to negative 7, then 7 to infinity. And that is 8. That's one of the hardest problems on this test. I can understand being overwhelmed if you haven't had any time to study, though. This is another one with tables. Oh my god. Okay, so we look for the x on the g side, that is 9, turns into 3. So then we are looking for f3. Here is 3. It is 1. Okay, and then there was the same questions as the test review quiz. Let me find it. Okay. A graph of f inverse is a reflection of the graph of f about the line whose equation is blank. Now, if f of x is this, and f of inverse of x is just backwards, then x is equal to y. And this is the answer to this question. Okay, and then f I'm gonna give you I'm not gonna say it so you can guess. Okay, guys, I literally can't even say what this is. I can't read it because that's the fucking answer. This means the what of the function of f. It's called f inverse. It's the inverse. Okay. Alright, then we have Okay, horizontal asymptotes are really easy. That's just the one with all the rules. If n is equal to m, then we do the leading coefficient of each divided by each other. If n is less than m, then y is always equal to 0. If n is bigger than m, there's no horizontal asymptote. So on top we've got x squared, so n is 2. On the bottom we've got x squared, so m is 2. N is equal to m. So we take 21 over 7, which is equal to 3. So the horizontal asymptote is y is equal to 3. Okie dokie. I believe I'm falling in love. I got 2 questions like this, so I'm just not going to erase all of this. So my other one was okay, on top we've got x, so that's an exponent of 1. On bottom we've got x squared, so that's 2. N is less than m. 1 is less than 2, and so y is equal to 0. Okay. Ain't that a kick in the head? Just find the domain of the rational function. We set the denominator equal to 0. We know that this must be excluded because when functions are fractional, the bottom cannot equal 0 because rational functions are not 0. Okay. I'm sorry guys, I've had like a really bad migraine thing going on for the past 2 days and I've got like migraine hangover, so explain as best as I can, but I might fuck up. I know these answers are right, though. This is it. That's really not hard. It's really not. Okay. Okay, this next problem is the last problem I had, and it's the hardest one I had on the test. And it ain't hard, so I don't know why this test was so easy. I write this so I make sure I don't forget what I'm looking for. Take my imaginary highlighters, highlight these so I don't forget what I'm looking for later, 'cause I will. Okay, we need to factor, so what adds to the middle value and what multiplies to the first and last. This is 1, so positive 21. I know it's 7 and 3. Got x minus 3. You can do the box if you need to do the box, but I don't need to do the box. It would literally... go this way. We have an x in common. This way we have negative 3 in common. Going this way, we have an x in common, and going this way, we have negative 7 in common. We pull out the negative because it is the closest to the line. So, x minus 3, x minus 7. Then we set those equal to 0. And then now, we know what to do for our sections. Negative infinity, 2, 3. 3 to 7, because we're working up from the negative end to the positive end. Just leave that there. Here we go, 7 to infinity. We have test points that are between these two values. We cannot use these values, so we can't use 3. It has to be in between. I'm going to do 0. Four, 8. Just plug it in to this, your simplified function. 0 minus 3, minus 3, minus 7. Turns into positive 21. We don't give a shit about the value. We just want to know if it's positive or negative. Okay, 4 minus 3, it's 1. 4 minus 7, that's negative 3. Negative. 8 minus 3, 5. 8 minus 7, 1. Positive. And because we are looking for greater than, we want all of our positive values. So, oops. Positive. And because it's not greater than or equals to, we're still going to exclude all these values, which just means we're just going to write with parentheses. And then on a number line, that would look like, let's go put 0 over here, 3, 7, Okay, we've got, oops, way too big. Negative infinity to 3, and it's parentheses, and then 7 to infinity. And that was the test. Okay? Alright. Godspeed, everybody.